Hello, this is Mrs. Ward, and I am going to go over section 9.7, graphs of polar equations. What we're going to do in this section is we're going to graph polar equations by plotting points. We're going to use symmetry as an aid to get sketching the graph. We're going to use zeros and maximum R values to sketch our graph. And then we're going to recognize some special polar graphs. The first thing you should know is that we are not doing everything in this section. We're being very picky about what we pick, what we choose to do, and what we choose to leave out. So when I first start this, graphing polar equations by plotting points is we're going to go back to when you first learned how to graph a line. If you remember that back in Algebra 1, you were taught to make an XY chart. You picked your X values, you substituted into the function, you picked your Y values, and then you applied the points. We're going to do something very similar when I start to do polar equations. I am going to plot the points. So I'm going to make a table, and I'm usually going to pick values that I know from my unit circle so that it will make the work go a little bit faster. I'm looking at my equation, which is R is equal to -4 sine theta. So remember, my input is my theta, my output is my R. So I am going to pick values for theta that I know. So I'm going to do 0, pi over 6, pi over 3, pi over 2. I skipped pi over 4. You can do pi over 4, but I didn't. And one of the reasons why I didn't, I don't know why I didn't. I just didn't. So when I substitute in -4, when I substitute in 0 for theta, so the first one is going to be R is equal to -4 times the sine of 0. Well, the sine of 0 is 0, so that's how I get 0. -4 times the sine of pi over 6. Well, the sine of pi over 6 is 1/2. That's how I get -2. I'm going to, so if I keep on going, I'm going to say R is equal to -4 times the sine of pi over 3. Well, the sine of pi over 3 is the square root of 3 over 2. So that's going to be -2 times the square root of 3 when I simplify it. So I'm going to say -2 times the square root of 3. Next one, I'm going to go up here. R is equal to -4 times the sine of pi over 2. So this will be -4 times 1, and so this will be -4. I'm going to plot the points that I have so far. So the first one, my theta is 0, which means this is my theta as being a 0. And my R value is also 0, which means I'm going to be at what used to be the origin, now called the polar axis. So the next point is going to be pi over 6. So I'm looking at pi over 6, this angle here for pi over 6. And I want a radius of a -2. Remember, if the radius is a -2, that means I sort of hop over the pole and go in the opposite direction. So I'm going to go over here, 1, 2, and I'm going to plot this point right there. That's going to be the next one. So then when I did pi over 3, I get -2 times the square root of 3, which is approximately -3.5. Close enough. So when I do pi over 3, here's the angle pi over 3. Now I'm hopping over the polar axis because it's negative. I'm going to go 1, 2, 3, and about 3.5. So I'm going to plot a point here. Pi over 2 is this line here. Radius of -4, so I'm going to go down 1, 2, 3, 4, and I'm going to plot this point right here. So I'm going to keep on going. If I do R is equal to -4 times the sine of 2 pi over 3, well, the sine of 2 pi over 3 is the square root of 3 over 2, which is going to be the same -2 times the square root of 3, which is going to be that same. So 2 pi over 3 is here. Negative, hopping over the polar axis. Hopping over 1, 2, 3.5. 5 pi over 6, so R is equal to -4 times the sine of 5 pi over 6. The sine of 5 pi over 6 is a positive 1/2, so that'll be -2. So -2. So 5 pi over 6 is here. And then -2, 1, 2, and I plot those points here. I'm going to erase this, all these lines, but I'm going to keep my points. So that's what I have so far. I also had one here. Pi, the sine of pi is 0, so if -4 times that will be 0. 7 pi over 6, the sine is -1/2. Sine of 7 pi over 6, so R is equal to -4 times that, so -4 times -1/2, so that's going to be +2. But looky here, when I do 7 pi over 6, that's this angle right here. +2 would be 1, 2. I'm going to end up duplicating some of my points. So when I do 3 pi over 2, that's going to be r is equal to -4 times the sine of 3 pi over 2. So r is equal to -4 times a -1. So r is equal to 4. So when I go to 3 pi over 2, which is this line here, I'm going to do +4, which is this point here. So at a certain point, you start getting the same points again. So at that point, you can stop. Now, the problem with polar is I'm not sure if this is a circle, a lemicon. So what I'm going to do at this point, once you're going to be expected to plot these points, but once you get this far and complete this table, you're going to pick up your calculator and you're going to graph. So let me show you how to do that. So I have my calculator. I'm going to pick it up. I'm just going to do a graphing page. I'm graphing in polar coordinates, so I need to tell my calculator that I'm going to graph in polar coordinates. So I'm going to hit Menu. I'm going to go to Graph Entry Edit, which we've used before to do the relations. Now I'm going to go down to number 5, which says polar. And see how this says R1? That's just like the f of 1. That's my first polar equation. I'm going to type in the polar equation I have, which is -4 and then sine. And then notice how this is theta. Since this is theta, I'm going to go down here to where the pi button is, and I'm going to get theta, because I have to have these two variables have to match. And you might be tempted to change it to an x, but then you'd have to change this one too. And I'm going to tell you about this one. This one says that I have a step. So what it's doing is it's picking values, and it's doing every 0.13 radians, because I'm in radians. So it's going to do 0.13. So I'll show you the different things in a second. But so when I hit enter, okay, when I go to graph this, I picked up my calculator. I'm on the calculating page. I'm going to hit Menu. I'm going to go Graph Entry Edit, because I'm graphing in a different coordinate system, so I have to let my calculator know. And I am going to go to polar. And then it says R1. This is just like f of 1, f2, f3 that you're used to from a function notation. I'm going to type in my equation, which is -4 sine. And you'll notice that there's a theta here, which means I have to use theta over here. To get that theta, I go down here to where the pi button is, and I'm going to go over here and grab theta. So that's the equation that I have, and I'll explain this in a second. If I hit enter, I can see that it clearly looks like a circle. So this graph that I started to graph is going to be, because it's going to be that circle. And I'll finish that in a second. I want to talk a little bit more about the calculator. If I go to, I'll get out of here. If I go to, let's go up here. See how this was, this is 0 theta. So this is doing one complete unit circle, because 6.28 is 2 pi. So it's doing one complete circle from 0 to 2 pi. This step, if I change this, and I can change this. Let's say I made this, well, let's make it a really big number 3, which is going to completely change the shape, because what it's doing is it's graphing like the negative sign of 3 radians, so it would be like -pi, and then it's graphing 6, and it's just going to make these big jumps. So it's going to change the graph. If you feel like your graph is choppy, then you're going to want to make that number smaller. So this is a very choppy graph. If I even made this even bigger, let's say I made this like 10, I'm not even going to have a filled out circle, because I'm missing all this stuff over here. So normally the go-to is just to leave it at that 0.13. So I'm just going to leave that at 0.13. And I'm going to have my circle. So that's just what that means. All right, so I'm going to go here and complete my circle. So remember how I said we're picking and choosing? This is one of the things that we're going to talk about and use to sort of help us. So you have polar graphs that are symmetrical. So if I go back here and I want to talk about symmetry, that means when one side looks like the other side. If I were to draw an imaginary line, and you did this in Algebra 1, if I were to draw an imaginary line here, straight down, this one half of the circle would map over to the other half of the circle. So the left side would look exactly like the right side. So that is a type of symmetry in polar equations, and that's going to be where it's reflective over the line pi is equal to 2. What used to be our y-axis is now the line theta is equal to pi over 2. So if I know that it reflects over this pi over 2, when I go to plot points, I only need to pick points from the first quadrant and the fourth quadrant, because then everything else can map over to the other side. And so I don't have to worry about plotting points from the second quadrant or the third quadrant. The trig function, the main trig function that is symmetrical with the line of theta is equal to pi over 2 is going to be my sine function. So anything with a sine, I know that I only have to pick points from the first quadrant and the fourth quadrant and then map them over. And I'll show you one in a second. Symmetrical with a polar axis. Remember, this is the polar axis. What in rectangular coordinate system would be the x-axis. That means that this will map over to this, which means if I want a complete curve, I only have to graph points from the first and the second quadrant, and those points would map below that polar axis. The trig function that is symmetrical with respect to the polar axis is going to be the cosine function, and obviously they're reciprocals. And the last one, symmetrical to the pole, which means the first quadrant looks like the third quadrant. That's the double reflection. It's like you map it over here and then you map it over here. It's a double fold when you did it in Algebra 1. So the trig function that deals with that is going to be a tangent function. Completely honest, in this class this year, not doing tangent functions, so we really don't need to worry about that one. Okay, so when I look at this, this is ways that I can check it. Again, you can. So if it reflects over the polar axis, it doesn't mean if I have theta or if I have negative theta, I'm still going to get the same R value. If the way I look at pi over 2 is if I have R or if I have theta and I change either one to negative, it changes both of them to negative. So that's, again, the pole is a tangent function. We're not doing that. So I already told you this. Sine is reflective over pi over 2. The line theta is equal to pi over 2. And cosine is reflective over the polar axis. So what does that mean, Mrs. Ward? Well, here I have this function, r is equal to 3 minus 2 cosine theta. I just said that cosine is reflective over the polar axis. And so if I go back here, that means I only need to do points from the first and the second quadrant, and then I can map them down to the fourth and third. So let's do this. I'm going to set up a chart. I'm going to do vertical because I like vertical better. Theta, R. I'm going to pick my main values that I know from my unit circle. I'm going to do 0, pi over 6. We're skipping pi over 4. You can do pi over 4 if that makes you happy. Pi over 3. Then pi over 2, and again, first and second quadrant. So now I'm going to do 2 pi over 3, just going around my circle. 5 pi over 6, and then finally pi. So when I do this, I'm doing 3 minus 2 cosine 0. Well, the cosine of 0 is 1. So this will be 3 minus 2, which will just be 1. So this will be 1. Can I go that fast? I think I can. 3 minus 2 cosine of pi over 6. So this is 3 minus 2 times the square root of 3 over 2, which is 3 minus the square root of 3. We'll get a decimal approximation for that in a second. 3 minus 2 times the cosine of pi over 3. So 3 minus 2, cosine is 1/2. So that's 3 minus 1. This will be 2. 3 minus the cosine of pi over 2, we forgot the 2 there, so 3 minus 2 times 0, so this will just be 3. 3 minus 2 times the cosine of 2 pi over 3, well, the cosine of 2 pi over 3 is a negative 1/2. So this is going to be 3 plus 1, so this will be 4. Do 3 minus 2 times the cosine of 5 pi over 6. So 3 minus 2 times the negative square root of 3 over 2. The 2's will simplify. Negative times the negative is positive. So this will be 3 plus the square root of 3. And finally, 3 minus 2 times the cosine of pi. The cosine of pi is negative 1. So that'll be 3 plus 2. And so this value will be 5. So this is how I'm going to plot it. I'm going to do 0. So I'm going to do 0. So 0 means my angle, 0, and 1. So that's going to be this point here. I'd map it over the polar axis, but it's on the polar axis, so that's not going to do me much good. I want to find a decimal for the 3 minus the square root of 3. And when I do that, I get a decimal that says it's approximately 1.3. Again, just approximate. So pi over 6 is this line here. And let me do that with a highlighter. And then I'm going to erase it. So pi over 6 is this line here. And I want 1.3, so a little bit more than 1. So let's say I put that dot here. Then because it's cosine and it's symmetrical over the polar axis, that means I have this imaginary line here. Well, I don't have an imaginary line, it's actually there. So I have this line here that goes like this. And once I have that point here, I'm going to map it down, sort of reflect over here, and I know that I'm going to have a point there. That's what the symmetrical rules do for me. They help me save time by just mapping. So I have a point in the first quadrant, map it to a point in the fourth quadrant. Okay, pi over 3 is going to be, is going to be this line here. And that is 2, so I plot that point here. Now reflecting over this line here, I'm going to map it down, and I'm going to have this point here. Then pi over 2 is going to be 3. So 1, 2, 3. Map it over the polar axis, which means it's going to come straight down, 1, 2, 3. And I'm going to have that point there. 2 pi over 3 was 4. So 2 pi over 3 was 4. So 1, 2, 3, 4. So that's there. Mapping it down is going to be right here. Imagine folding this piece of paper on this. Now I'm going to change it over this purple line. So the points on top should match the points on the bottom. They should be as far over to the left as they were. So now the next one is going to be 5 pi over 6, and then 3 plus root of 3, which as a decimal is, drum roll please, 4.7. So that's going to be off my graph. Sorry about that. So 5 over 6, 4.7. Let's say that's about here. Map it's about there. And then the last one was pi 5. So pi 5 would be about here. And so I'm going to guess that it's, well, I'm going to say that goes something like this. Kind of have that little divot in here. And now I'm going to verify on my calculator that that's the graph that I should have. Okay, I'm ready. The graph, I'm going to hit menu. You should still be on polar if you just graph polar, but I'm going to do polar. I'm putting in that equation, which was 3 minus 2 cosine theta. So 3 minus 2 cosine. And again, remember theta's down here. Hit enter. And I have this. And this shape that has like this little divot in here is called a limicon. So you don't have to ever be able to identify. I'm never going to ask you to say it's a limicon, but I'm telling you it's a limicon. And there are graphs in the polar world that have that little divot. So it's not a circle, it's a limicon. And that matches what we got because I forgot to go through that dot there. All right, moving on. So if I were to graph this one, and I'm not going to, but if I were to graph this one, I would do the same setup, except for since this is a sine curve, when I go to make my XY chart or my R theta chart, sine reflects over the line theta is equal to pi over 2. So I'm not, when I do my theta R chart, when I do that, I'm going to pick values from the first quadrant. So 0, pi over 6, pi over 3, pi over 2. But I'm not going to pick values from, since it reflects over this line here, when I get a point here, it's going to map over here. So I'm not going to do anything from the second quadrant. And then I'm going to jump down to the next one I'm going to do is probably the fourth quadrant. So I'm probably going to do, going in order, 11 pi over 6, 5 pi over 3, and then 3 pi over 2. And I kind of went backwards, but I did 11 pi over 6, 5 pi over 3, and 3 pi over 2. And then once I get the points on this side, I'm going to map them on this side. That's using the symmetry as a guide, as an aid. Okay, let's talk about zeros and maximums. Well, here's the thing. Usually we spend so much time in the rectangular coordinate system talking about zeros, 0, 0, zeros, when's my x-intercept, because those are so important. But in a polar equation, if my r is 0, like if I graph the point 0, 5 pi over 6, well, I can go to 5 pi over 6, but I'm graphing zeros. That's going to be there, which is not going to be any different than 0 pi over 2, because this r means that you're not traveling anywhere. You're staying at the polar axis. So the pole, I should say. So the zeros really don't help. We're going to find them, though. You're still going to have to tell me when you have zeros. And then you're going to have your maximum R values and your minimum R values. So when I go to find my zeros, let's talk about the zeros first, because they're kind of intuitive. When I find my zeros, that means I'm going to put 0 in for R. And then I'm going to remember trig. And I'm going to solve this equation. So I'm going to subtract 1 from both sides and divide both sides by 2 and get -1/2 is equal to the sine of theta. And then I sit here and I ask myself, when is the sine of theta equal to -1/2? Which means I have to know my unit circle. And the sine of theta is negative in the third and the fourth quadrant. So my angle has to be from the third or the fourth quadrant. And the sine is equal to 1/2 with a denominator of 3. So I'm going to say 4 pi over 3 and 5 pi over 3. And that's what theta is equal to. So those are my zeros. My zeros occur at theta is equal to 4 pi over 3 and theta is equal to 5 pi over 3. So those are finding my zeros. So if I had to graph 4 pi over 3, 4 pi over 3 is here. That's still going to be here. 5 pi over 3 is still going to be here. Doesn't really help me graph. Okay. Now let's talk about the max and the min. So when I look at a sine function or a cosine function, I have, remember when we graph these, because we did graph them, sine and cosine fluctuate between the max for sine of theta is 1. The lowest a sine of theta can be is -1. So the highest my sine value can be is 1. The lowest it can be is -1. So to find my max and my min, I'm not going to be sure which one is which until I actually do the work. So here's my equation, y plus 2 sine theta. Well, I just said the most that sine theta can be is 1. So I'm going to put a 1 in here, because that's the highest that sine of taking the sine of any angle can be. So if I have 1 plus 2 times 1, and when I do that, I get 3. And then over here, the lowest sine theta can be, here's my sine theta again, the lowest this can be, the smallest number can be, is -1. So when I do that, I'm going to have 1 minus 2, which is -1. So my whole function, when I plot this on my paper here, all the numbers are going to be between 3 and -1. Well, since 3 is the maximum, I'm going to say my maximum is 3, max of r is equal to 3. That's the largest my radius is going to be. Since -1 is smaller, I'm going to say that I have a minimum of -1 when r is equal to -1. That's going to be the smallest, which means I'm going to flip over the polar axis. Now, that's identifying what my r values is. So my max or my y value in rectangular system would be 3. So that's my r, 3 and -1. So the furthest away from the origin that one point's going to be is on this radius line here. And then the smallest would be on this radius here. Now you need to tell me when that occurs. And this is where we might have some trouble. So when does the sine of theta? So now I'm going to ask you, when is the sine of theta equal to 1? Well, hopefully you can tell me that's when theta is equal to pi over 2. So my max is going to be my theta, my 3 and pi over 2. That's my max. My radius is 3 when my sine is pi over 2. What is my min? So I'm asking, when is the sine of theta equal to -1? Because that's what I put in here was -1. And hopefully you know that happens at 3 pi over 2. So the minimum is going to be -1, 3 pi over 2. So this would be my max because the 3 is larger. This would be my min because the -1 is smaller. So that's how I find my zeros and my max and my min. And here's just the pictures of the different graphs. I feel like I really want to do another one, but I'm not going to. So you'll notice on your note sheets that you only have the rose curves, because the rose curves are the ones that will show me whether you know how to find your zeros and whether you know how to find your max and your mins. And it's the easiest one to graph. And so we're just going to focus on the rose curve. In order for a function to be a rose curve, it's going to be in the form of r is equal to, you're going to have a number outside, then you're either going to have cosine or sine. You have to have a number in here. Let's say it's 3 and then theta. That's what a rose curve will be. It'll either be sine or cosine. It does not change. The sine or the cosine change where the petals are, and I call them petals, where the petals are, but it doesn't change the shape. It's just a matter of where the petals are. So let's show you what I mean by how the rose curve helps me. So here, I'm going to do r is equal to 4 cosine theta. So when I go back here and I see if n is equal to 3, I have 3 petals. If n is equal to 4, I have 8 petals. So if n is equal to 5, I have 5 petals. If n is equal to 2, I have 4 petals. So the rule is if n is odd, then you have n petals. If n is even, then you take 2 times that, and that's how many petals you have. So if I said r was equal to 3 cosine 5 theta, that means there would be 5 petals. And we'll go through how you find those petals in a second. If I had r is equal to 3 cosine 6 theta, that means I would have 12 petals. Okay, so let's go through graphing one. So r is equal to 4 cosine 2 theta. So first thing I'm going to do is I'm going to find my 0. Let's find my 0. Yeah, let's find my 0. So 0 is equal to 4 cosine 2 theta. Divide both sides by 4. 0 is equal to cosine 2 theta. So I'm going to sort of ignore the 2 for a second, and I'm going to ask myself, when is the cosine of theta equal to 0? Well, the cosine is equal to 0 at pi over 2 and 3 pi over 2. That's when the cosine is equal to 0. So this is equal to 2 theta, because I have to still take into account that 2. So I'm going to say pi over 2 is equal to 2 theta, and 3 pi over 2 is equal to 2 theta. So when I divide both sides by 2 or multiply by 1/2, I'm going to get pi over 4, and I'm going to get 3 pi over 4. Divide by 2. So again, so if you think about it, this is pi over 4. That's a 0. That's this line here. If I reflect it over here, it's also going to happen at 7 pi, or yeah, 7 pi over 4. 3 pi over 4 is the other one it told me. 3 pi over 4 is 0. When I map that down here, because remember cosine's reflective over the polar axis, it's going to come down here. So it's basically going to be anything with a denominator 4 is going to be a 0. Great. Now let's talk about my max. The max of this function is 4 cosine 2 theta. Well, forget about the 2 for a second. If I just had 4 cosine theta, the most that this can ever be is 1. So I take 4 times 1 and get 4. So my max R value is going to be 4. And here's a hint. Whatever number this is in front, that's going to be your max. That's pretty simple. The hard part is I have to figure out when that happens. So normally the cosine of theta is normally equal to 1 when theta is equal to 0, which doesn't really help me. So I'm going to go 1 unit around the circle and say 2 pi. Then I'm going to say, well, there's a 2 here. So I'm going to say 2 theta is equal to 0. So theta is equal to 0. And then the other one, and 2 theta is equal to 2 pi. So theta is equal to pi. So I'm going to have my maxes are going to be 4. That's what I already said. It's going to be one angle is going to be 0, and the other angle is going to be pi. The more angles you can find, the better you're going to be. So 4, 0. So here's my angle 0, 1, 2, 3, 4. There's going to be the max of one of my petals. The other petal we said was going to be at pi. So pi is my angle. That gives me a max of 4. Well, I'm going to go back. So those are the 2 points that I used. I used that finding my max values. Then I'm going to ask myself, well, this is a 2. That's even, which means that there are 4 petals. What's nice about this is the petals are equally spaced apart. So I have 300, I usually do degrees, or you could do 2 pi. I have 360 degrees. That's one whole lap around my unit circle. I have to get 4 petals in those 360 degrees. So if I take 360, I'm going to get 90. So there's 90 degrees between tip of petal to tip of petal. Well, here's one tip. The next one has to be 90 degrees away from that, so it's going to be here. The next one has to be 90 degrees away. That gives me this one here. And then finally 90 degrees will give me here. And then if I do 90 again, I end up here. And I have 4 peaks or 4 maximums, so those are going to be my 4 peaks. And really don't care how wide or narrow you make those petals, just draw 4 petals. So that's how you draw a rose curve. Okay, so I'm going to start by finding my zeros. 0 is equal to 2 sine 3 theta. So divide both sides by 2. 0 is equal to sine 3 theta. So you're basically ignoring this 3 for a second, and you're asking yourself, when is the sine equal to 0? When is the sine of x equal to 0? And that happens at 0, pi, 2 pi, every multiple of pi. So I'm going to set each one of those equal to 3 theta. And when I do that, I get theta that equals 0, theta that equal pi over 3, and theta that equal 2 pi over 3. So at 0, pi over 3, and 2 pi over 3, I know I'm not going to have any petals. It's going to be 0 is going to be my radius. Then I look, I'm going to find my max. So I'm going to say R is equal to 2 sine 3 theta. And then I ask myself, when is the sine of theta normally equal to 1? So when is the sine of x equal to 1? And you tell me that it happens at pi over 2. So I'm going to say r will equal, the max would be 2 times 1, so r is equal to 2, which I knew because that's the number out in front. And then that's going to occur when 3 theta is equal to pi over 2, so theta is equal to pi over 6. So I know one of my petals is going to be at pi over 6. So I'm going to graph that. So pi over 6, 1, 2. I remember that sine is reflective over the line y is theta is equal to pi over 2, so I can plot I can map out the other one over here. So I have 2. I know 3 theta. This is my n. N is odd, which means that there are 3 petals. I have 360 degrees. Divide that by 3. There's 120 degrees between petals. So if you want to change this to degrees, this is 30 degrees. This is 150 degrees, which makes sense as 120 apart. And then if I add 150 to 120, I'm going to get 270 degrees.